Okay, so problem 3 is just figuring out some limits. Um, okay, so let's just start with A here. So the way limits work is you think, what is the limit as t goes out? Well, I'll just plug in t and then, oh damn, it doesn't work when I plug in t, and because somebody who bought a $22 million house from the money that I paid for my textbook has created this problem to make it impossible to plug in T. And so then there's always some, what's going on here? Um, sorry. So there's always some algebraic trick that you have to do, and then after you do the algebraic trick, you can cancel something, and then after you cancel, you can just plug in. So let's look at this thing. All right, so what do you think the algebraic trick is going to be here? So first, notice what happens if I plug in 2. On the bottom, I get 0. Okay. So then, well, it does make sense to go on to ask what happens when you plug it in on the top, because suppose you plug 2 into the bottom and you get 0, and you plug 2 into the top and you get 8, then the answer would just be infinity and you'd be done. It's really easy. So the pain is what happens when it's also 0 on top. And what do you bet, James Stewart, um, that that rich Canadian has engineered this problem to also make 0 come out when you plug it in on top. So let's see, 4 plus 2 is 6 minus 6. This is 0 over 0. So it could be anything. Okay, and so these are the ones where you actually have to think a little bit. So they're kind of the only ones we worry about, because the other ones are what a mathematician would call trivial. So the trick here, the algebraic trick that we're going to do, is to factor the top. So if you factor the top as a polynomial, then I was going to say that it probably has a factor of t minus 2, but in fact it definitely has a factor of t minus 2 because we just plugged 2 into it and 0 came out. So it's t minus 2 times something. So what could it be? So we need two things that multiply to negative 6 but add to 1. And so it's going to be, I know you're screaming it, but I can't hear you, so I have to just do it myself. It's going to be t plus 3 times t minus 2. Okay, I just factored this polynomial, and if you are uncomfortable factoring polynomials, then we need to talk. And you could also get some help with that online, I'm sure, over at the Khan Academy or Wikipedia. And we still have this t minus 2 on the bottom here. Okay. Notice that I did not write equals the limit as t goes to 2, which is what I should do, so that it's really equal. And now strike this out. And we get this is equal to the limit of your tolerance for bright colors on the computer screen. This is equal to the limit as t goes to 2 of t plus 3. So now you should always be ready to have something where the answer is a no-brainer. There will be cases where you can just plug the number in and you're done. And so this is a case like that. There's no reason not to just plug in 2. And when you plug in 2, you get 5. And so the answer is 5. Okay. Alright, so now let's look at B. Maybe I should copy it because it looks like we're going to run out of space here. So B is the limit as x goes to 3 of 2x plus the absolute value of x minus 3. Okay. And this is one of those cases where there's absolutely no reason not to just plug it in. So it's almost like a trick question. So what happens if you plug in 3? You get 6 plus 0. And so does the universe fold in on itself, or is there some kind of paradox about... No, there's nothing wrong. It's just 6. So the answer is 6, and so that's because if you plug in 3 here, you get 6 plus 0 is 6. Okay. Alright, very easy. And now this one is tricky. It'll make up for that other one being too easy. So let's look at the limit as t goes to 2 from the... So this plus here is telling you that t is coming towards 2 from the positive side, so that's the right hand side. And then the expression is the absolute value of t minus 2 over regular old t minus 2. Okay, so let's take a look at this. Now I want to be clear about what this plus means, so I'm going to say it again. If you've got the axes, and so here's 2 on the number line, what the plus means is that we're creeping up on 2 from the side that the positive numbers live on. So in other words, the right hand side. Okay, so since 2 is coming from the positive side, we could cheat a little bit and just think of t as being like, what is t when it's just a little bit to the right hand side of 2? It's like maybe 2.1. So what happens when you put in 2.1 here? Get the absolute value of 2.1 minus 2 over 2.1 minus 2. So what is that going to do? So on top you get 0.1, and on the bottom you get 0.1 equals 1. And it probably is not a hard sell here to convince you that it is 1, okay? But now I feel bad because that wasn't much of an argument, and if you didn't believe it, then all I could tell you is that you have good instincts, because that was not a very good mathematical argument. So, alright, so how do you give a more solid argument for it being 1? You can do it like this. So if t is to the right of 2, which it will be because that's what the plus promises, then t minus 2 is always going to be positive. Okay, so if you have something bigger than 2 and take away 2, it's positive. So that means the absolute value signs are not doing anything in that case. So what you really have is t minus 2 over t minus 2. The limit as t goes to 2 from the right hand side. And that is clearly 1. Okay, so that was a little more solid, alright? And so we've done all three, A, B, C. So the problem is over.